Hello everyone, I am Abhijit Lal, Assistant Professor, Department of Electrical and Electronics Engineering, BIT Durg. Today we are going to study about Zener Diode. The contents will be the introduction of Zener Diode, working principle of Zener Diode, then we will study about different specifications of Zener Diode. After that we will discuss the VI characteristics, then the types of breakdown which occurs in Zener diode. After that we will see the difference between PN junction and PN junction diode and Zener diode. We will study about the equivalent circuit of Zener diode, and lastly we will cover the applications of Zener diode. Now what is Zener diode? A heavily doped PN junction diode that works in reverse bias condition is called a Zener diode. Now here the words to be noted is heavily doped. Normal PN junction diode is having some impurities. We have studied in the past lectures that PN junction diode is formed by inducing the impurities in the semiconductor materials. So the level of doping can be changed, it can be increased or decreased. So to form a Zener diode, or to make different from a normal PN junction diode, the doping is increased, and the diode which is heavily doped is called as the Zener diode. And second thing to be noted here is that the Zener diode works in the reverse bias condition. As we have studied for the normal PN junction diode, it allows the current to flow during the forward bias condition. That means the diode will be in on condition when it is in forward bias condition, and it blocks the current at reverse bias condition. So what is different here is the Zener diode works in reverse bias condition. So it is a specific diode that works in reverse bias conditions. It allows the current to flow in both forward and backward directions. So this is another important property as we can compare it with the PN junction diode. PN junction diode only allows the current to flow in one direction, that is from anode to cathode, whereas Zener diode allows the current to flow from both the direction, that is forward or backward. So from where the word Zener is derived? So it is derived from the name of the scientist which bring the concept of Zener diode. His name was Clarence Melvin Zener of Bell Labs. He was the first man to describe the electrical properties of Zener diode. He was the first to tell about this special diode that works on reverse bias conditions. So the diode is named after him, that is Zener diode. Zener effect. An electrical breakdown occurring in the reverse bias condition of the PN junction diode is called the Zener effect. So we have seen the breakdown occurs in both the direction, that is in the forward bias condition also and the reverse bias condition. So but the breakdown which occurs in the forward bias condition is called as breakover part, and that breakover voltage is noted. But in the reverse bias condition, the breakdown occurs, the electrical breakdown occurs is called as the Zener effect, and at that condition of the PN junction is called as the Zener effect. So in this condition, when the electric field increases to a high value, it enables the tunneling of electrons from the valence band to the conduction band of a semiconductor, which suddenly increases the reverse current. So the Zener effect is nothing but the principle of working for the Zener diode. In this, what happens is that the electric field, when electric field increases to a high value, it allows the electrons to flow from valence band to the conduction band, and in this way the conduction of current takes place in Zener diode. The breakdown or Zener voltage depends upon the amount of doping. We have discussed during the PN junction diode also, the doping plays a very important role. So the breakdown or the Zener voltage also depends upon the amount of doping. More the amount of doping, the more the amount of the breakdown voltage will be present, and vice versa also. So if the diode is heavily doped, the depletion layer will be thin. That means the depletion layer, the thickness of the depletion layer depends upon the amount of doping. So if the diode is heavily doped, the thickness of depletion layer will be thin, and consequently the breakdown of the junction will occur at a lower reverse voltage. As we have seen in the VI characteristics of PN junction diode, we have discussed about the avalanche breakdown. That means when the reverse voltage is increased to a certain value, a certain point occurs where a breakdown occurs, and that breakdown is called as the avalanche breakdown. So if we want to obtain the breakdown before the avalanche breakdown, the doping should be increased. That means that PN junction, in PN junction diode, when the it is made heavily doped, that breakdown can be obtained before the avalanche breakdown, and this is the working principle for the Zener diode. So a lightly doped diode has a higher breakdown voltage. So doping is increased, we can have the breakdown voltage to a very small level. So it works in this fashion only. When a diode is heavily doped, its breakdown voltage is less, and when it is lightly loaded, its breakdown voltage is more. This figure shows the circuit of the Zener diode, or we can say that the symbol of Zener diode. The sign is slightly changed with the diode, but it is having the same two terminals, that is cathode and anode. One part is added, and that bar, the shape of bar is different, which differentiate it with a normal PN junction diode. Now let us discuss about the working principle of Zener diode. So if the reverse bias voltage is less than the breakdown voltage, or if it is forward bias, then it acts as an ordinary diode. This means that forward bias allows current to flow and reverse bias blocks the current from flowing. This is the working for the normal PN junction diode. After this, the voltage surpasses the breakdown point in reverse bias, and the diode falls in the Zener region, where it gets conducted without getting damaged. So current in this region is known as avalanche current, but for a Zener diode, it is also known as a Zener current. So when the breakdown occurs in the reverse bias condition, and if it occurs before the avalanche breakdown, it is called as the Zener breakdown, or we can say that Zener effect, and the current which flows here is called as the Zener current. When the voltage decreases in the circuit, the diode maintains its non-conducting condition and gets back to its natural properties. This specific property of the Zener diode of being functional in the reverse bias and with avalanche current is given by the rich doping of the semiconductor material present in it. By controlling the amount of doping of the semiconductor material, and by doing this, the thickness of the depletion region in the PN junction and the breakdown voltage can be set to any value according to the need of the appliance. This means that thickness of the depletion region, that depends upon the amount of doping, and this thickness of the breakdown of the depletion region decides the amount of breakdown voltage. So more the doping is done, or we can say that if the diode is heavily doped, the depletion region will be thin and the breakdown voltage will be less, and if the doping is less, the depletion region will be, the thickness of the depletion region will be more, and the breakdown voltage will be more for that, and so on. Let us study about the specifications of a Zener diode. So these are the particular specifications, or we can say that the ratings for the Zener diode which should be known, or which should be displayed with the diode itself. So first one is Zener or breakdown voltage. So the Zener or the breakdown voltage varies from 2.4 volt to 200 volt, and sometimes it can go up to 1 kilovolt, while its maximum value for the surface mounted device is only 47 volts. So there are the different ranges for different applications. The Zener diode are made for which the different breakdown voltages are fixed. So that is mentioned as the rating, or we can say that Zener or breakdown voltage. Next is the power rating. So the power rating indicates the maximum power that a diode can disperse, which is given by the product of the voltage of the diode and the current flowing through it. So the maximum power rating is also displayed with the Zener diode so that its capability can be known. Next rating is current, or we can say that the maximum current rating of the Zener diode. So it is the maximum current reading at the rated Zener voltage which is Vz, it is noted by Vz, maximum Zener voltage. So the range of current obtained will be 200 microampere to 200 ampere. So this will be the maximum current reading for the Zener diode. Next is the voltage tolerance. The voltage tolerance is basically plus or minus 5%. So the variation in the Zener diode, the variation of voltage in the Zener diode can be plus or minus 5% of the rated value. Next is minimum current reading. So it is the minimum value of the current reading required for the diode to break down. So the minimum current required to obtain the breakdown in the reverse direction is the minimum current reading of the Zener diode. Next is the temperature stability. So the Zener diode has the best stability of around 5 volt. So around the voltage level of 5 volt, it is having the best temperature stability. Next is Zener resistance Rz. So it is the resistance that the Zener diode offers during the working condition, and it is denoted by Rz. Now let us discuss the VI characteristics of diode, of Zener diode. So the following picture shows the VI characteristics of Zener diode. So this is very similar to that of PN junction diode. The difference occurs here is between the avalanche breakdown and Zener breakdown. So in the reverse bias condition, or in the reverse bias region, we can see the amount of voltage goes on increasing in the negative direction. So a particular point occurs where the avalanche breakdown occurs. So the Zener breakdown occurs before the avalanche breakdown, and as we have studied, the condition for that is the amount of doping is increased. So if the amount of doping is increased, so we can obtain the breakdown before the avalanche breakdown, and that is called as the Zener breakdown. So in this way, the two types of breakdowns are different from each other. So this VI characteristics of Zener diode shows the two types of breakdowns in the reverse bias region, and in the forward bias region it works similar to that of the PN junction diode. So the VI characteristics of a Zener diode are divided into two parts, which are mentioned as follows. The first one is forward characteristics. The first quadrant of the graph depicts the forward characteristics of a Zener diode, and from which we can understand that it is almost similar to the forward characteristics of any other normal PN junction diode. So Zener diode is normally a PN junction diode. Its working is similar to that of PN junction diode in the forward region, or when it is in a forward bias condition. So the forward characteristics is also similar to that of a normal PN junction diode. Now what changes is the reverse characteristics. So let us study about the reverse characteristics. When a reverse voltage is applied to a Zener voltage, a small reverse saturation current, which is denoted by I0, flows across the volt diode. This current is present due to thermally generated minority carriers present in the diode. So as the reverse voltage starts to increase at a certain value of reverse voltage, the reverse current also starts to increase drastically and sharply. Now let us study about the types of breakdown in Zener diode. So as we have seen in the VI characteristics, there are two types of breakdowns, that is avalanche breakdown and Zener breakdown. So two types of breakdown occurs in Zener diode during reverse bias condition, and they are called as avalanche breakdown and Zener breakdown. So what is avalanche breakdown? The phenomena of avalanche breakdown occurs in both ordinary diode and Zener diode at high reverse voltage. So here the condition for the avalanche breakdown is that it occurs at a very high reverse voltage. That means at a permissible level, if we are increasing the voltage in the reverse direction, a point occurs where the breakdown occurs in the diode, and the current increases very drastically and very sharply, and that condition is called as the avalanche breakdown of the diode. So it is same for both the ordinary diode and Zener diode. For a high value of reverse voltage, the free electron in the p-n junction diode gains energy and acquires high velocity, and this high velocity electrons collide with other atoms and knock electrons from that atoms. So when the voltage is increases in the reverse direction, the free electron in the p-n junction, they gain energy and they acquire very high velocity, and this high velocity electrons, they gets collide with the atoms, and they knock the electrons from the atoms. In this way the free electrons gets created. Now after this, this collision continues and new electrons are available for conducting current. Thus the current increases rapidly in the diode. So the reason for the drastic increase in the current and the sharply increase in current is the collision process and the development of the new electrons. So more and more electrons gets available, and due to this the value of current goes on increasing in the reverse direction. So this phenomena of a sudden increase in the currents is called the avalanche breakdown. Now this phenomena damages the diode permanently, whereas the Zener diode is a specific diode that is made to operate in this reverse voltage area. Now the difference here between the p-n junction or the ordinary diode and Zener diode is that if the doping level is nominal, or it is the in p-n junction diode, when the doping level is nominal, lightly doped, and if the voltage is increased in the reverse direction till the avalanche breakdown occurs, so the heavy current which flows during the, or the very high current which flows in the reverse direction, that will permanently damage the normal p-n junction diode. But in case of Zener diode, it is designed and manufactured in such a way such that this reverse direction current will not damage the diode, but it will help, and it will the working region for the Zener diode. That is why the Zener diode is a specific diode that is made to operate in this reverse voltage area. Now what is Zener breakdown? The Zener breakdown happens in heavily doped p-n junction diodes. So the basic difference between the p-n junction diode, Zener diode, is the doping level. Zener diode, the doping level is very high, which allows it to work in reverse bias condition and in the reverse region. So in these diodes, if the reverse bias voltages reach closer to Zener voltage, the electric field gets closer to the electric field gets stronger and is sufficient enough to pull electrons from the valence band. That means if the reverse bias reach the Zener voltage, the electric field is so strong that it is sufficient to pull the electrons from the atom, or we can say that the electrons starts moving from valence band to the conduction band. So this is how in Zener diode the current starts flowing. So these electrons then gain energy from the electric field and break free from the atom. So as the electric field gets stronger, it pulls the electrons from the valence band, and they gain energy, the electrons gain energy, and they break from the atom, and they becomes the free electrons, and this is how the flow of current gets started. Thus for these diodes in the Zener breakdown region, a slight increase in the voltage causes a sudden increase in the current. So due to this, if we further increase the voltage, a very slight increase in the voltage will cause the field to get much stronger, and that pulls the electrons very easily from the valence band to the conduction band, and more electrons move from valence to conduction band, and they are the free electrons, and due to this there will be the sudden increase in the current. So this is how the current starts flowing in the Zener diode during the reverse bias condition. Now let us see the difference between the avalanche breakdown and Zener breakdown. So in avalanche breakdown occurs when the high voltage increases the free electron in the semiconductor and a sudden increase in current is seen. So here the increase in the current, or we can say that the current starts flowing when the voltage is made to increase in the reverse direction, and that voltage, increase in the voltage, causes the free electrons to move from valence band to the conduction band. So what happened in Zener diode? The Zener breakdown happens when electrons from the valence band gain energy and reaches the conduction band, which then conducts electricity. So what happens in Zener breakdown is that the electrons get the energy from the electric field, the strong electric field, and they move from valence band to conduction band, and this is how the current starts flowing in the Zener diode, and Zener breakdown occurs. An avalanche breakdown is seen in the diodes having breakdown voltage greater than 8 volts. So this makes the another difference. The breakdown voltage is greater than 8 volts during the avalanche breakdown, whereas Zener breakdown is seen in the diodes having breakdown voltage in the range of 5 to 8 volts. So in Zener diodes, the Zener breakdown voltage, or we can say that the breakdown voltage lies between 5 to 8 volts, but avalanche breakdown starts after the 8 volt. That means the breakdown voltage is greater than the 8 volts. Next difference is the avalanche breakdown is observed in diodes that are lightly doped, whereas Zener breakdown is observed in diodes which are highly, or we can say that heavily doped. So this is the main difference between the normal p-n junction diode and the Zener diode, and this makes the difference in the breakdown also. So avalanche breakdown occurs in the lightly doped semiconductor device, or the diode, whereas the Zener breakdown occurs in highly doped p-n junction diode. In the avalanche breakdown, the VI characteristic curve is not as sharp as the VI characteristics curve in the Zener breakdown, whereas in Zener breakdown it is having a sharp VI characteristics curve. That means the current flows in the reverse direction very sharply, and it increases very drastically. For avalanche breakdown, increase in temperature increases the breakdown voltage, and for Zener breakdown, increase in temperature decreases the breakdown voltage. So this is also a main difference between avalanche breakdown and Zener breakdown, in which the temperature plays their role in different ways for both the breakdown. In avalanche breakdown, if the temperature increases, the breakdown voltage will be increased, whereas during the Zener breakdown, if the temperature increases, the breakdown voltage will be decreased. So these are the differences between the avalanche breakdown and the Zener breakdown. Now let us see the difference between the p-n junction diode and the Zener diode. So in Zener diode, it allows the current to flow in both directions, which means that its current can flow forward as well as in the reverse direction. But a p-n junction diode allows current to pass only in one direction, which is a forward direction. So this is the important difference, is the main difference between the p-n junction diode and a Zener diode. And the flow of current in p-n junction or an ordinary diode is only in the forward direction, whereas in Zener diode the direction of current in both the ways, that is forward and reverse direction. The Zener diode has high doping, whereas p-n junction diode has low doping. In a Zener diode, a reverse current has no effect on Zener diode, whereas a reverse current effects on a p-n junction diode can be a damaging part for the diode. If the reverse current increases beyond its maximum rating, it can directly damage the diodes. So in Zener diode, a breakdown occurs at a lower voltage in a Zener diode, and a breakdown voltage occurs at a higher voltage in a p-n junction diode. So as we have seen in the VI characteristics of Zener diode as well as VI characteristics of p-n junction diode, the breakdown occurs at a very high voltage in the negative direction in normal p-n junction diode, whereas the breakdown occurs in Zener diode before the avalanche breakdown of a normal diode. So in this way, less voltage is required to be applied in the reverse direction for a Zener diode. A Zener diode does not follow Ohm's law. This is a very important point here. A Zener diode does not follow the Ohm's law, whereas a p-n junction diode follows the Ohm's law. Now let us see the equivalent circuit of Zener diode. Here this picture shows the equivalent circuit of a Zener diode in which the voltage across the Zener, which is called as the Zener voltage, or we can say that the breakdown voltage is shown in the form of a battery. That means a voltage source, a current is flowing Iz, and the voltage here is the V, capital V. The analysis of circuits using Zener diode can be made easy by replacing the Zener diode by its equivalent circuit. So the Zener diode works again in the two states, that is on state and off state. So let us see about the on state. When reverse voltage across a Zener diode is equal to or more than breakdown voltage Vz, the current increases very sharply. In this region, the curve is almost vertical, which means that the voltage across Zener diode is constant at Vz even though the current through it changes. Therefore, in the breakdown region, an ideal Zener diode can be represented by a battery of voltage Vz. Under such conditions, the Zener diode is said to be in on state. So, in on state, the Zener diode is simply denoted by a battery, or we can say that a voltage source whose voltage is Vz. The second state is off state. So, when the reverse voltage across the Zener diode is less than Vz but greater than 0 volt, then the Zener diode is in off state. Under such conditions, the Zener diode can be represented by an open circuit. It means that when the voltage, the reverse voltage is increased up to the voltage Vz, that means before the Vz, and it is not raised up to the Vz, then it at that time, up to that time, it will remain in the off state. So, to make the Zener diode work in the reverse bias direction, the reverse voltage should cross the value of Vz, and if the voltage rise between or it remains between the Vz and 0, the Zener diode will remain in the off state, or we can say that the Zener diode does not conduct. So, the following figure shows the equivalent circuit of a Zener diode in the off state. The first figure shows we have seen that shows the circuit diagram or equivalent circuit diagram of Zener diode in the on state, where the Zener diode was denoted by the voltage Vz, or simply a battery or a voltage source having the value Vz. But in off state, the Zener diode is nothing but it is denoted by as open circuit, since no current flows through it. So, it is very necessary to make the Zener diode to work. The voltage should exceed Vz, then only the and that voltage should be reverse voltage. The reverse voltage should exceed the value of Vz, and after that only the Zener diode will start working and the current starts flowing in the reverse direction. Now, let us discuss about the application of Zener diode. So, Zener diode is a very special kind of diode. It is used for various applications, various special applications for which the normal or ordinary p-n junction diode is not suitable. So, the first application of Zener diode is as a voltage regulator. So, the Zener diode is used as a shunt voltage regulator for regulating voltage across small loads. So, first thing which should be noted here is that it is used for the voltage regulation. Voltage regulation means varying the voltage for the small loads, small rated loads. So, the Zener diode is connected parallel to the load to make it reverse bias, and once the Zener diode exceeds the knee voltage, the voltage across the load will become constant. So, this is how the voltage is regulated in small rated loads by using the Zener diode. The breakdown voltage of Zener diodes will be constant for a wide range of currents. So, that is why the Zener diodes are used for the voltage regulation purposes, since the breakdown voltage of Zener diode will remain constant for the different values of currents. Next application of Zener diode is in over voltage protection. So when the input voltage is higher than the Zener breakdown voltage, the voltage across the resistor drops, resulting in a short circuit. This can be avoided by using the Zener diode. So the most important application of Zener diode is in the protection scheme. So it can be used for the over voltage protection purposes. So when the Zener diode is used here to limit the current. So if a current increases at a particular level, and due to this or directly or indirectly the voltage increases beyond a certain rating, that can be limited using the Zener diode. So in this way Zener diode finds its application in the over voltage protection. Next application of Zener diode is in clipping circuits. So what is clipping circuits? They are also called as the clipper circuits. So the Zener diode is used for modifying AC waveform clipping circuits by limiting the parts of either one or both the half cycles of an AC waveform. So there is a circuit which is called as the clipper circuit, whose work is to clip, or we can say that remove some part of the output voltage, or that means to obtain the output according to the requirement by clipping the either the positive part or the negative part or both the part using the certain diodes. So Zener diode founds its application in clipping circuits. So what it does is that it removes the part of the output, or the so suppose AC current is given to the Zener diode in a particular diode circuit, we can obtain a certain part of it at the output. That is done by clipper circuit. So our Zener diode find its application in clipping circuits, where it can clips or removes the part of the cycles or AC cycles either from the positive half or from the negative half, or can be removed from both the parts. So these are the various applications, and this application, that is the clipping circuit about the clipper, we are going to study in the coming classes, and as well as in the coming lectures we will study in detail about the application of Zener diode as voltage regulator, because these two applications of Zener diodes are very important and they are widely used in different electronic circuits. So in this way, in today's lecture, we have studied about the introduction and the difference of Zener diode from an ordinary diode. We have discussed the difference between the VI characteristics of Zener diode and ordinary diode, and the different breakdown which occurs in a diode, and the applications of Zener diode. Thank you.